Since we know -1 is the root of the polynomial function, we can use the syntactic division to break down the function by using this point. So we write down the 2, -1, 97, 49, and the -49. Draw the box here. You put the root -1. This is the root, so you just copy down exactly the same number here. Now drop down the 2. 2 multiplied with -1, you get a -2. Something on the function wrong here. This is a positive x power 3. So let me change it. Okay. Now 1 plus -2, you get a -1. -1 multiplied with -1, you get a positive 1. Sum these two, you get a 98. Multiply 98 with -1, you get a -98. Sum these two, you get a -49. Multiply with -1, you get a positive 49. So that's why the remainder is 0. Now this 4 on your quotient part here, this -9 represents the constant term. 98 is the x term, x squared term, x power 3 term. So if I reorganize this polynomial function, I can rewrite it into, this is the root, right? So when I reflect the root back to the factor form, you should have x plus 1. That's the only way you get the root is -1. Now we continue to structure the rest of part of the polynomial function. We have 2x power 3 minus x squared plus 98x minus 49. Okay, now because these pieces of the polynomial function still has a large set, so I'm going to continue to use the same process to break down this polynomial function by using all the steps we just went over. So now I'm going to finding the all possible rational zeros, p over q. Same way, the constant term has 49, so we will have 1, 7, and 49 over your q is the leading coefficient term, so it has 1 and 2. Now all possible rational zero, they are all the list here. 1, half, 7, 7 half, 49, and 49 half. Same way, I'm going to start with the 1 because this is an easier number for me to produce. So when I have the 1, plug in only this part, okay? Because this is a polynomial we're still struggling with. This part we already solved it. The root is 1. So now we are only working on these pieces. When I have the 1, substitute into this part of the function. So minus 1 squared plus 9 multiplied by 1 minus 49. Alright, so with this one, it gave me, okay, let me see, what do I have here? We have 2 minus 1 plus 9 minus 49. So for sure, I will not get a 0. Plug in -1. So we have 2 -1 power 3 minus -1 squared plus 9 multiplied by -1 minus 49. For sure, this one, I won't be able to get a 0 as well. Now we try another number. We try the half. So when I have p of half, plug in here, you can do the calculation, alright? But when I have the p of half substitute into this part of the function, it gave me the 0. So now I'm going to use the synthetic division to depress this part of the polynomial function into another pieces. So we do the work here. Now, so synthetic division, let me copy down the function here. So the p of x, we had x minus 1, 2x power 3 minus x squared plus 98x minus 49. Okay. Now we just determine p of half is equal 0 for this part of the polynomial, right? So we go with the synthetic division to break down this function, this part of the function, by using the half. So the root is half. Now drop down 2, half multiply with 2, you get a 1. Sum these 2, you get a 0. Multiply with 0, you get a 0. So 98. Multiply half with 98, you get a 49. Now your remainder is 0. So this is a constant term. X term, x squared term. So we reorganize p of x. We have x minus 1. And then these three terms, they are the quotient, right? They are the quotient of the polynomial. And we have another root is half. So let me write down x minus half, right? The root is half. That means the factor form is x minus half. Then multiply with x squared. Since the x term is 0, we don't need to write down. Just put the plus 98 here. Now from here, I can start to solve for x by using the zero factor theorem. These pieces, we know x equal 1. From these pieces, we know x equal half. From these pieces, we can solve for x by bring the 98 to the right hand side, so you'll get a negative 98. Take the square root on both sides, so your x is equal plus minus square root negative 98. Now keep in mind, with the square root sign, we don't want the number under the radical is a negative sign. So we rewrite the square root negative 98 into the square root 98 multiplied with square root negative 1. Negative 1 is the I. Square root 98, we can break down this number. Alright, so 98, when I find the perfect square number, we start from 2, right? So 98 divided by 2, we will get a 49. 49, we can break down to 7. So the perfect square number will be 7. So we have 7 power 2 multiply another 2. Now we can bring the 7 to outside of the radical sign. So you have plus and minus 7 root 2i. So this polynomial function has 4 solutions, right? Because our from the original function p of x, the leading coefficient term was 2x power 4. So we have the 4 solution. When we solve for this polynomial function, by the end, we should have 4 solutions. And those 4 solutions is this one, x equal 1. The second solution is x equal half. The other 2 solutions, they are from here, positive 7 root 2i. Another solution is negative 7 root 2i. Now keep in mind, this polynomial function, you have 2 real solutions, or 2 real zeros. 2 non-real zeros. Non-real zeros. Or you can call 2 imaginary solutions. So this is a work of your on 4.5.